Standard 10, exponential growth. Here is your second learning target. I can use exponential models to represent investments. This time we're talking all about money. In particular, money that when you put it into account, it compounds interest, which means it gains interest over certain intervals. So in this problem, you will continue to explore exponential growth. When investing money, exponential growth is sometimes called compound growth. Let's talk about college funds, you guys. Mrs. Ramos started college funds for her two granddaughters. She gave $1,250 to Cassie and $2,500 to Kaylee. Mrs. Ramos invested each fund in a 10-year bond that pays 5% interest a year. Okay. Write an equation to show the relationship between the numbers of years and the money in each fund is what it should say. Let's talk about Cassie first. Y equals, how much money was Cassie given right away? $1,250. And hers is gaining interest, right? It keeps 100% of its value plus 5% of its value. Okay, and now we need to put 105% in a decimal. 1.05. So we could say it's 1 plus 0.05. 100% plus 5% to the power of X. Cool? Now let's talk about Kaylee. Kaylee was given $2,500, which does not seem very fair to me. And that also pays 5% every year. Now there's a reason that I'm writing it like this. So I'm going to now add those two things together, 1 and 0.05, because I can. It's really easy to do that. And these are your equations. All right. Make a table to show the amount in each fund for years 0, 1, 2, and 3. So at the beginning, we already know Kaylee has $2,500. And Cassie has $1,250. And we're going to use those equations to figure out how much they will each have after year 1, 2, and 3. Okay, so let's see. You're going to want Desmos open for this for sure. And what I want you guys to do is you're going to go Y equals, and we will do Kaylee's first, which is this equation right here. So that would be 2500 parentheses. Caret is shift 6 and then X. Now I am going to, so did you guys see what I did there? You're going to click on the gear and the table. And this is going to show us I just typed a 3 and I scroll down and type a 3. How much money she will have after each year. So 2,625. And this is only if she doesn't touch the money. 2,756. I'm just going to round. And $2,894. So as you guys can see, the amount of money in Kaylee's fund increased over time. So after 3 years, she will have increased her amount by $394. Now let's talk about Cassie's fund for a second. Cassie's fund is almost the same, except for we type in $1,250 because that's how much she started with. So after 1 year, it's $1,000 $313. That's not where commas go in numbers. 1378 and 1447. So I'm going to write this down. Look from here to here. Kaylee added $394 over 3 years. Let's look at this one though. That's not even $200. 97. Wait, does that make sense though? They both increased by the same amount exponentially. What does this tell you about the amount of money you put in when you're gaining interest? You want to put in the most you can because your interest is based on that amount of money. So the more you put in, the more it'll gain every time. Does that make sense? So they both have the same interest rate. Doesn't matter how much money is put in at the beginning. Yes. To make more, invest more. All right. I mean, obviously, Cassie's not going to have as much as Kaylee, but if you look at how much money was increased, that's not a ton of money. Cool. All right. Now, this is what happens after this interest is compounded every year. See how we're dealing with years here? Every year. Now we're going to talk about interest that doesn't compound every year. It compounds more than that. So let's see. Mr. Gray wants to start a college fund for his newborn son, George. He has $800 to invest. He has found 3 different types of investments to make. One, where they all have the same interest. It's all 12% interest rate, which is pretty high, but it compounds at different times. When you say compounds early, that means once a year, 12% is added on or multiplied on, okay? When it says quarterly, that means 4 times a year, 3% is added on because it isn't 4 threes the same as 12. So it equals 12%, but it breaks it down. So 4 times a year, 3% is added on. And when it says compounded monthly, that means 12 times a year, 1% is multiplied on. It gains 1% of its value, but 12 times a year. Does that make sense? Because 12 times 1 is 12. If this number was different, these percents would be different. I wonder which one's going to make the most money. It seems to me like the once a year being 12% would make the most money over time, because even though you're compounding interest 12 times a year, it's only 1% each time. Let's see what happens. This is how we do this. This is going to be a little scary. You're going to be fine. Y equals your initial investment, 1 plus, it keeps 100% of its value, plus your rate over the number of times a year and how many years times how many times a year. Don't fret, don't freak, don't do anything bad. Let me show you. Let's go to the one that compounds yearly. This is just like the one we did in the last example. It compounds, so 12%, And I want to know for 1 year. It's going to compound once then, if we're talking about yearly. However, if we're talking about quarterly, that is 4 times a year. So, and then 1 times 4. So that's going to be 4 times per year. And if we talk about monthly, that is the rate 12 times a year, 1 times 12. Okay. This is how you would figure this out. Which one do you guys think is going to be the most? Compounding yearly, quarterly, or monthly? Well, let's figure it out. So we're going to go to Desmos. And I'm going to say 800, 1 plus 0.12, caret 1. $896. This here is $896 is how much George will have after 1 year. Now, this one gets a little scarier. One thing you guys need to do in your head is this here. 1 times 4 is 4. So watch how this works. I need to divide that by 4, and that needs to be 4. Whoa. So if it compounds quarterly, which means 4 times a year, of $900, that's a big difference. I thought I didn't think that was going to be bigger. I mean, it's not that big of a difference, but it's more than compounding yearly. Let's try this one. 1 times 12 is 12. So I'm going to go back to Desmos. Ooh, $901. Interesting. Looks like compounding monthly, you get more. Let's see what would happen after 10 years. 10 years, you would go like this. 1, this is compounding yearly to the power of 10. That's the easiest. It's when we go to compounding quarterly that things get a little exciting. Remember, compounding quarterly, you divide by that rate by 4, and you go 10 times 4. So what's that going to be? That's going to be 40. And then this here, and this would be 10 times 12, which is 120. All right, let's see how much George will have after 10 years using each of these. So I'm going to do this one first. Holy cow, $2,640. $2,640 after 10 years. Now I'm going to type in the quarterly one. So I'm going to divide by 4 and to the power of 40. $2,610, we'll call that. Let's see annually. If the interest compounds annually, we want to know 10 years, and we do not divide. Whoa, $2,485. Which one would you pick, you guys? Which one would you pick? I would pick compounding monthly. If I was Mr. Gray, I would easily pick the one, even though you're only increasing by 1%, you're doing it so many times a year that it actually really adds up or multiplies up. Mwahaha. All right, let's see how much money George will have when he goes to college. Let's do 18 years. This is annually or every year. So 18. This here is compounding quarterly. So this is going to be 18 times 4, which I'm going to type that into a calculator. And this guy here is 18 times 12. Definitely typing that into a calculator. So if Mr. Gray uses the one that compounds interest once a year, the whole chunk once a year, George would have, for 18 years, $6,152. $6,152. Now let's do a compounding quarterly. So this means we have to figure out what 18 times 4 is first. 18 times 4 is 72. So remember, divide your decimal by the 4, and then this is going to be 72. $6,720. Ooh, that's a big jump. Now let's see what happens over here with compounding interest monthly. So I need to do 18 times 12. It's 216. Also, you guys need to remember to do that. $6,863. So let's review. If you are picking, like Mr. Gray, between the same interest rate, but it compounds differently, you want to pick the one that compounds the most throughout the year. That's going to get you the most money. George, if Mr. Gray picked compounding yearly, he started with $800, and by college, he would have $6,152. It's not bad. Quarterly, he would get more after 18 years, and monthly, he would get even more. All right, so I hope you guys understand how these work. Yeah, these are investments that you guys might be making someday. So exciting. Or if you guys see anything like that at the bank when you have your like bank accounts, sometimes you guys will get like a interest statement or something. Interest rates, by the way, are not like 12%. That's pretty hefty and amazing. If they are, I do it because, like, look, if you don't touch your money, you get a whole bunch of free money, but you can't take anything out in between these years here. Anyway, that's how interest works.